Hello friends, welcome to Power Electronics lecture series. Myself Mr. Yuval. Okay, today in this particular session we are going to do the experiment, that is a three-phase fully controlled converter with resistance as a load and by using PSIM software. Okay, so this is the desktop of PSIM software where we need to go with this new. Okay, this is the new experiment and save it. So we will give the name like three-phase fully controlled converter with R load. Okay, using PSIM software. Okay, save it. Now we came on this particular workspace. So here we will try to get detailed practical knowledge, that is simulation practical knowledge. Experimentally we'll try to understand how this three-phase output and three-phase input will be given and what are the switching sequences will be provided for these switches. Okay, so totally there are 6 switches are used. Okay, you can use any switches. Okay, so here you may find the MOSFET, you can find the IGBT, you can find some other diode, okay, as well. So as we are talking about the controlled converter, we will take a thyristor as a switch. So go to the element in the power. Okay, then you take a switch and go to the thyristor. Okay, so here we'll rotate it. Okay, so element, then power and the switches, and go to the thyristor and rotate this particular thyristor, so thereby we'll get according to our convenient. Okay, so I'll connect one thyristor here and the second thyristor at this position and the third thyristor I'll put it at this. Okay, and same thing in the lower limb I will try to provide some other 3 switches, that is thyristors only. 1, this is 2 and this is 3. So that means there are total 6 switching devices which we are using here. And the same thing, so in this particularly we will take previous class, as you can observe that we have taken separately this AC source voltages, but now we will take a 3-phase source supply. Okay, go to the element and then power. Okay, then you can go with this okay, sources. Okay, so there voltage we required and 3-phase sine wave supply. Okay, so directly you will get this and you just paste it here. Okay, so it's okay. Then we required to take a load, that is resistance as a load we have taken. So we'll take it resistance as a load. Yes, this is the resistance. Okay, just rotate it and just connect it here, somewhere here. Okay, yes, fine. And we required to measure the output current and the output voltage. To measure output current, we require an current probe. Okay, so this is the current probe. You just pick it and try to connect at this. Okay, then what we required an voltage probe, so that is available here. So voltage probe, you just select it and just rotate it and you just place here, so thereby we can able to get the output voltage. Okay, and apart from this, now we will try to connect all the devices internally by taking this wire. Okay, so connect it like this in the proper way to avoid by getting the errors. Okay, so here we'll take it, we'll shift it little bit in the correct way. Okay, and then again this particular connection has to be done in a proper way. So if you want, you can put it in a proper alignment, so thereby to get to not get the errors. Okay, and which will looks good as well. Okay, fine. Again, as you know that, so this particular connection has to be done. Okay, okay, yes, and you just move it. Okay, so I think it is looking fine. Take it and connect it. The same thing, you connect all these terminals. Don't leave any terminal to avoid the errors, okay, which will be generating. Yes, and from here just connect here. Okay, so therefore, so this tip, okay, one minute. Otherwise select it and delete it. Once again you just take it. Why we are doing? Because sometimes we will get the error. Okay, so to not get those errors, we will perform properly. So again we'll take it, okay, and then connect it, and these also you just connect it. Okay, and this, yes, very good, it is looking very fine. Now I will connect this the voltage probe as well. So this is the voltage probe, and connect it in a proper way. So this is the input source voltage, that is 3-phase AC source voltage. You just give it connection to at this, and second one is, so you can give it to this point, and the third one is you can give to this particular point. Okay, and finally we require a 3 voltage probes, because we need to observe the input waveform. Okay, 3-phase input waveform we need to observe. So for that I will take this voltage probe, okay, and I will rotate it and connect it at this first supply phase and second, and this is for third, and just join all these. Okay, so this is connected to this particular line, and it is connected to this, and this which should be connected to this. Okay, and all these 3 should be joined in a proper way, like this. Okay, yes, it has been connected. Now try to make a habit to save it. Okay, so then we required a gating block, so you just take gating blocks. There are total 6 gating blocks are required to perform this particular practical. So you connect all the 6 gating blocks to the gates of the thyristors, all the thyristors, like this. Okay, yes, fine, it is good. Okay, then we need to give a proper naming. So this is also very important, because if you give a proper naming, so then the output and input, whatever you are expecting, so that will be getting a good and it will be understandable to you all. Okay, so here what we'll do, I'll name this, I will put the specifications. So here I will take it as a 230 volt. Okay, so it is giving a line to line. Okay, so therefore 230, and the frequency which we select, it is 50 hertz. Okay, so these are the 2 changes you can make it, and if you want you can call it as a sine B sine. Okay, that is 3-phase. Okay, yes, you can give it any name if you want, otherwise you just put it same thing. So 230 and 50 hertz we have given. Then so after this we select this inputs. Okay, so take it V1. Okay, V1, that is input, V1 in. Okay, it is better, it is more clear. Okay, then this, it is V2 in. Okay, next it is V3 this is V3 in. So thereby we can get these three input waveforms. Okay, then so we'll mention this current probe as well. So in the current probe, so we will take it as a V naught. Okay, otherwise you can take it as I out, that is output current. So that also we need to measure, and you take this the voltage probe, thereby we mention it VO, that is output voltage. Yes, and the resistance we will take it, this is the R load, and the resistance will be 100 ohm resistance. Okay, so likewise we have taken these parameters, and the remaining is to set the names of all the thyristors and providing the gating pulse. Okay, so these are the two steps remained. Okay, then provide the names for these thyristors, or make the sequences for all the thyristors. So take how many different modes of operations are taking place. So if it is three-phase fully controlled converter, there are total 6 modes of operations will be taking place. Okay, so during each mode, there are 2 switches will be turned on. Okay, during each mode 2 switches will be turned on, one from upper limb and the one from lower limb. So likewise, so there are total 6 different modes of operations will be taking place. Okay, there are total 6 modes of operations will be taking place. So during first mode of operation, so this you can look at this, so this switch and this switch will be turned on. So therefore in the second mode, so the switch this and this will be turned on. Okay, so likewise we need to make a proper sequences to conduct these three-phase converter. Okay, so therefore we will try to give the names. Okay, so this we will take it as a thyristor 1. Okay, and then just put it the name thyristor 1, and this is thyristor 3, then thyristor 5. This is the thyristor 5. Okay, yes, and then this is the thyristor number. You can give the numbering as per your convenient. So this will be the 2. Okay, so we are giving according to our practical setup. Okay, so this is, I have given a 2 thyristor 2, and then this is thyristor 6. Yes, it is already mentioned, so no need to make any changes in that. And this is the final, that is, okay, we'll click on this, and this is the thyristor 4. So likewise total 6 thyristors have been mentioned here. Okay, and the last step to configure this particular experiment is that we need to provide the gating pulses or the firing sequences or the conduction angles. Okay, so that is a required thing. So you can see during first mode of operation, this thyristor 1 and thyristor 2 will be turned on. During second mode of operation, thyristor 2 and thyristor 1 will be operating. Okay, firstly initially 1 and this 6 will be turned on, and then this thyristor 6 will be turned off, and thyristor 2 and thyristor 1 will be turned on during second mode. During third mode of operation, thyristor 3 and 2 will be turned on. So this 3 and this is the 2, thyristor 2 is turned on. Okay, likewise all the modes of operations will be performed or will be conducted. In fourth mode of operation, thyristor 4 and 3 will be conducting. This is the 3 and the 4 thyristor will be conducting. And during fifth mode of operation, 5 and 4 thyristor, this is the 5 and the 4 will be conducting. And at the finals, during mode 6, the thyristor 6 and 5, this is the 6, 5 and 6 will be conducting. And after this, the same thing, this 6 and 1 thyristor will be conducting. Okay, so likewise the different 6 modes of operations it will be performed. Okay, it will work based on the 6 different modes of operations. So during each mode 2 switches will be conducting if it is 120-degree conduction path. Okay, then if it is 180 conduction path, then from upper limb there are 2 switches will be turned on at a time, and one will be from lower limb. If it is after this or 2 from lower limb and 1 from upper limb will be conducting, so at a time during each mode. So we are talking about 120-degree conduction mode. So thereby 1 from upper limb and 1 from lower limb will be conducting. 1 switch from upper limb and 1 switch from lower limb will be conducting if it is 120 degree conduction mode, because each switch will conduct for a period of 60 degree. So 60 plus 60, it is 120 degree. So therefore at a time for each mode there are 2 switches has to be turned on. So that is the condition is 1 is from upper limb and 1 is from lower limb. If both are conducting at the upper limb or lower limb, so it will be short circuited. So to take care of that, then we will try to provide the firing sequences. Okay, so for this T1 I will provide, so this is the G1 and the frequency is 50 Hertz which we have given. This is G1 gating 1, and here what I will provide, I will provide the sequences from 60 degree to 65. Okay, then you put it as a mark, and then for this T2, then a thyristor 2 gating pulse. So this you just replace with this 2 and the frequency 50 Hertz. Here the switching points are from 120 to 125. Okay, 125. So this is for thyristor to gating pulse, and then we'll take for third thyristor gating pulse. So you just make a change for this 3. Frequency is 50 Hertz, and then the switching points are from 180 to 185. Okay, and click here to display the values which you have given. After this, do for the thyristor 4, and same thing, a thyristor 4 just mention here, and the frequency is 50 Hertz. The switching points are for this thyristor 4, it is 240 to 245. Okay, likewise we'll take it, because 180 plus 60 will be 240, and 240 to 245 we want the sequence. Okay, and the remaining is T5, and this T5 is again mentioned G5. The frequency also provided 50 Hertz. The switching points are for this thyristor 5 is from 300 to 305. Okay, so therefore this will be 240 plus 60 will be 300. So therefore accordingly we have selected these values. Okay, you can take as per your convenient. If you get thorough clear idea about how to perform this practical, so based on that you can perform the other values by putting the other values or other switching sequences. You can put it, and you can change the other frequency as well, the supply, whatever the supply you have given. You can do it so many number of things you can do it in this. Okay, so there are multiple possibilities are there to do. So the same thing we will provide the sequences for this gate 6, and the frequency which we are operating, that is 50 Hertz, and then the switching points are for this 360 degree to 365 we have taken this. Okay, so now everything is perfectly good. Okay, the number of points for all the switching points are 2 only. Okay, so this we need to keep in mind. Okay, for 180 degree somewhere it will changes. Okay, so that we need to look after that. Okay, if you are trying to do that, you can keep in mind. So there are two switches will come like that. There are 4 points has to be mentioned. Okay, so that point has to be remembered while you are doing for 180 degree conduction mode. Okay, so then this everything is looks good and perfect. So the thing is that we need to take a simulation control. So you just take it simulation control and put it here. Then total time is 5 and put it. Okay, we have taken a simulation control. Okay, then we will try to run this particular simulation practical. Okay, so I will press it and try to run it. Okay, everything is fine here. Okay, we have done it proper way, so therefore it has not shown any errors. Okay, so these are the variables. So earlier what variables we have used earlier, which we have performed, so those variables are input, output. Okay, and now here you can see there are 1 2 3 4 5 variables. Okay, the number of variables will be based on what parameters you want to observe. Okay, so therefore initially I will do it by taking these three. Okay, v1, v2, v3. Okay, you can perform it by separately as well. So this particularly it will shows a three-phase waveform. Okay, it's looking very nice. Okay, so phase A, phase B and phase C, three or has been given here. Okay, so therefore we will try to understand by taking what is the output voltage. Okay, so we will take this as a output voltage and we will try to add it and do it. Okay, and then this is the output voltage where we can get it. Okay, so apart from this you can calculate the average value, power factor and the real power, and this is the apparent power and total harmonic distortions. All the values you can calculate by clicking on this, automatically it will calculate. Okay, so this is the output voltage and this is the three-phase input supply voltage. And if you want to measure the output current which we have given the current probe, so based on that, if you want, you can just check it the current as well. Okay, so this is what your three-phase fully controlled converter with resistance as a load. So in the next practical we will try to calculate or observe the output by using the RL load, that is resistance and inductance load we will use. Thank you for watching.